All right, you guys, we made it to our last video. Combinations again. Let's look at our example. A basketball team has 12 members who can play any position. How many different ways can the coach choose 5 starting players? Does order matter? Now, if you notice, we didn't assign positions to the 5 starting players, just who are your 5 starters. You pick 5 people, you pick the same 5 people in a different order. Is that considered a different group of starters? No, it's not. So this is a combination because the order does not matter. So our combination formula, NCR equals n factorial on top over r factorial times n minus r factorial. So in this example, n is going to be our total number. We have 12 total members of the team. We're going to choose 5 as starters. And how many different ways can we do this? So we're going to plug in. We've got 12 factorial on the top. Our r is 5, so 5 factorial times 12 minus 5 factorial. Let's take care of that subtraction. 12 factorial over 5 factorial times 7 factorial. Okay, let's start writing out our 12 factorial. You guys know where we're going to stop? 12 times 11 times 10 times 9 times 8 times 7 factorial. Because we have a 7 factorial in the denominator, that we're just going to cancel those out. I'm going to start with 5 factorial though. 5 times 4 times 3 times 2 times 1 times 7 factorial. Your 7 factorials are canceled, and now we try to do some reducing, canceling between the denominator and numerator. So first thing I notice is we have a 4 and a 3, which multiplies to 12, and there's a 12 on top. So 4 times 3 is 12, canceling with that 12. I also notice we have a 5 times 2, which is 10, and there's a 10 in the numerator. So 5 times 2 is 10, canceling with that 10. The only thing we have left down here is a 1, which doesn't change the value of anything, so we're just going to multiply 11 times 9 times 8. And we're going to get 792 different ways that the coach can choose 5 starting players.